Okay, Chem 121, this is the last part of the lecture on Module 1. I promise I won't add any more. I just wanted to do this topic a little bit more justice and to have you sort of have a separate lecture so you could focus on it. And this is such a critical skill is problem solving in terms of general chemistry. You have to think critically, you have to analyze the data that you're given in order to come up with an approach. So let's talk about how to solve problems in chemistry problems, in general chemistry, and then the dimensional analysis method or factor label method that you should be using from now on. So let me share my iPad. Okay, so I also want to get rid of this. So most chemistry problems that you're going to solve in this course are going to be unit conversion compounds or problems. And using the units as a guide is something that's called dimensional analysis. My units should always be included in my calculations, and they are multiplied, divided, and canceled like any other algebraic quantity. If you use this method and you use this unit conversion dimensional analysis, your units are going to tell you whether you've set something up correctly or whether you flipped a conversion factor or whether it makes sense in terms of the way that you've set up the problem. So dimensional analysis is a method that's going to use conversion factors that are converting a quantity expressed in one unit to an equivalent quantity in a different unit. Conversion factors are the relationship that is expressed between those two different units. For example, I know that 1 inch is equivalent to 2.54 centimeters. That's a conversion factor that I can get off any chart of relationships. And this is where I'm going to start with this equivalency statement anytime I want to actually do a problem like this. This is the basic setup here. I start with what's given. I multiply by the conversion factor. And then what I'm going to get is the equivalency in this new unit that I'm talking about. So it all is based on these equivalency relationships that we're going to call conversion factors. So a unit equation or an equivalency statement is going to be the relationship which identifies the same thing. So 2.54 centimeters is the same thing as 1 inch. A conversion factor is going to be a fractional quantity. I can always derive 2 conversion factors from every unit equation or equivalency statement. So I could have 2.54 inches over 1 inch, or I could have 1 inch over 2.54 centimeters. And notice I'm going to include the units. The units we are converting from are always on the bottom, and the units we are converting to are on the top. And that makes sense if you think about the factor label method. Here is an example of a chart where I might get these different unit conversions from. We've got different types of conversions. I have metric to metric. I have English to metric, metric to English. I have English to English. Those are different types of conversions that I have. You do have to take note of your significant figures. if I'm working within the same system, like English and English, like I know 1 gallon is equal to 4 quarts. That's a definition, unlimited significant figures. I know 1,000 grams is equal to 1 kilogram. That's a definition, unlimited sig figs. If I want to take 1 kilogram, I'm gonna measure how many pounds it is. So that relationship is gonna have 4 sig figs. So in that situation, when I look at a measure, I'm defining what a kilogram is by measuring it in pounds. So the measured part of that equivalence is going to determine the significant figures. If I have 1 kilogram over 2.205 pounds, or the inverse, this relationship is going to count for the 4 significant figures from this particular measured part of that conversion factor. So most unit conversion problems take the following form. I have my given, and then here is the conversion factor. My given unit is going to cancel because my units can multiply and divide just like numbers. So if I have centimeters over centimeters, the centimeters is going to cancel. Well, because my undesired units are canceling and my desired unit is on the top, now I've just done the conversion. So here's an example. How many meters are in 69.5 inches? This is a measured number. I have 3 sig figs, right? Just so you know, when I start doing calculations, I have to use my sig fig rules in order to report the final answer. So here's my relationship. I get off a chart that 1 meter, that's what I'm defining, is equal to 39.37 inches. This relationship is worth 4 significant figures from the 39.37 inches. I can get 2 conversion factors. I can get this guy or the inverse. This one is going to convert inches to meters because meters is on the top. This one is going to convert meters to inches because inches is on the top. So I have to choose. If I start out with inches, I'm going to use this conversion factor because I want to be able to cancel the inches when I set up my conversion. So this is what it looks like. Here's my given, 69.5 inches. My conversion factor is, I know for every 1 meter, I have 39.37 inches. Inches is going to cancel out with inches. I'm left with meters. So now I know that that is going to be the desired unit that results in my calculation. This is 4 sig figs. This is 3 sig figs. I'm doing a multiplication or division. So I'm going to use the sig fig rules for that. So I need to report 3 sig figs because this number is determining the number of sig figs in my answer. So whatever I get, I'm going to round to 3 sig figs. So this is going to be the answer to this conversion. Here's another example. If a car travels a distance of 241 kilometers, what is the distance in miles? Well, from my table, I'm going to find the equivalency statement. I know that 1 kilometer is equal to 0.6214 miles. I got that off of some table that I had online, right? Here's my given. Here's my conversion factor. I want miles on the top and kilometers on the bottom so I can cancel out my kilometers, and that gives me miles as my answer. So you're always going to set it up so what I want is on top The unit that I want is on top. The unit I want to cancel is on the bottom. And then I end up with the final answer. This is 3 sig figs. This is 4 sig figs. So I'm going to report 3 sig figs in my final answer. Now, this is a way to report the number 150 and make this zero significant. If I put it into exponential notation, that means that all 3 of these digits are significant. The other way I could do that to make 150, I have to remember that 0 is at the end, so that's ambiguous. But if I put my decimal place there, that also turns this into 3 sig figs. So this one has 3 sig figs. This is ambiguous. So you have to be careful for that. Sometimes if my result is an ambiguous number, I'm going to use either a decimal point like this, or I'm going to use scientific notation in order to make a 0 significant and fulfill the significant figure reporting requirements. Now, density. Density equals mass over volume. That's an algebraic equation. But I can also use reported density values as a conversion factor, right? If I know that the density of iron is equal to 7.87 grams per milliliter, I know that I have 7.87 grams of iron for every 1 milliliter of iron. This is the equivalency statement that I get out of a density. I can use this form or this form, depending on if I want to convert from grams to milliliters or from milliliters to grams. If I want to say, okay, I have 8.533 grams of iron, and I want to see how many milliliters that is, I want milliliters on the top so I can cancel out grams. That gives me 1.08. How do I get that? 4 sig figs, 3 sig figs. So I get 3 here. That's my answer. If I want to convert the volume, here I'm given 1.08 milliliters. What is the mass of that volume of iron? I'm going to put milliliters on the bottom so it can cancel, grams on the top, and then I'm going to get the grams of iron. Again, I have 3 sig figs. I have 3 sig figs. So I'm going to get 3 sig figs in my final answer. This is a really important use of density. Really pay attention to using conversion factors and not just solving an algebraic equation. We will be using conversion factors from now until the end of time. If you're going to take any other chemistry classes like Gen Chem 2, you want to be especially sure that you use conversion factors as your mathematical tool to solve chemistry problems. Otherwise, you are going to run into trouble. I guarantee you that the more complicated we get, if you don't use conversion factors, you will run into severe headaches. So let's try this. Acetone has a density of 0.787 or 57 grams per centimeter cubed. This is also equal to milliliter. Remember, 1 centimeter cubed is equal to 1 milliliter. So if I have 18.5 milliliters, this is also saying it's 0.7857 grams per milliliter. I can interchange centimeter cubed with milliliter. So what this is saying is my equivalence statement is this. I have 0.7857 grams of acetone for every 1 milliliter of acetone. So this is the basis for my conversion factor. So here I have the given. I want the conversion factor where I have milliliters on the bottom, which gives me 0.7857 grams of acetone on the top. I have 4 sig figs and 4 sig figs, so I want to report 4. When I do this math, milliliters is going to cancel out. Grams is going to be the unit. So I'm going to get 14.73 grams of acetone as my final answer. In my next problem, I'm going from volume to mass. It's still acetone, so I still use the same conversion factor. My given here is 7.89 grams of acetone. I'm now going to use the form of the conversion factor where grams is in the bottom and milliliters is in the top because I want to convert to the volume. So I put a 1 here and I put a 0.7857 grams down there. Grams are going to cancel. And what I find out is that is equal to 1.00 milliliters of acetone. I want 3 sig figs because I'm starting out with 3, which means I have to make those zeros significant. So I'm going to place them after the decimal. I can't just say 1 milliliter because that's only 1 sig fig. I want 3 sig figs, so I'm going to add these zeros to make 3 significant figures. Now this is plus or minus 0.01 milliliter in terms of my certainty, which is much different than if I just said 1 milliliter. Here's another problem that's a little bit more complicated. It also uses density, right? It says find the radius of an aluminum cylinder that is 2 centimeters long and has a mass of 12.4 grams. So I have this problem. I have a cylinder, right? My height of my cylinder, or the length of the cylinder, is 2.0 centimeters. My radius, right? This is what I want to find. And I know the volume of this cylinder is pi r squared times the length. I also know that I have a density which relates mass to volume. So all I have to do is figure out the volume of the aluminum. How can I do that? I have a mass of an aluminum. I have a density of an aluminum. So I have 12.4 grams of aluminum. My density, again, I have 2.70 grams of aluminum for every 1 centimeter cubed of aluminum. I want grams to be on the bottom. I want centimeter cubed to be on the top. I'm going to go ahead and get my calculator out. I have 12.4 divided by 2.70, and what I get is 4.59259 blah, 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 blah. I'm significant to the 3rd digit because I have 3 sig figs and I have 3 sig figs there. Well, now I have the volume. So that problem just gave me V. I know pi and I know L. So I can solve for the radius. So what I have, and this is going to be centimeter cubed. So what I have is 4.59. I'm going to leave it off right now, but in my calculator, I'm going to use it. Centimeter cubed is equal to pi r squared times 2.00 centimeter, right? So I'm going to divide by pi and 2. That's going to cancel that. So what I'm going to have is 4.59 divided by parentheses pi times 2.00, and that's going to give me 0.7305 blah blah blah. I'm significant to the 3 again. Centimeters cubed is equal to r squared. Now, to get r, I'm going to take the square root of both sides. This would be centimeter squared because it's r squared and r is a centimeter value. So I'm going to take the square root of each side, and what I'm going to do is I'm going to get second square root of that answer, and I'm going to get 0.854 centimeters. Actually, this is centimeters, so this is centimeters squared because 1 centimeter canceled there. If I take the square root, I get 0.854 centimeters is equal to r, and that's going to be my final answer. So you can see that I can take a fairly complicated equation, a fairly complicated problem, and if I work through it rationally, I'm actually going to end up with the correct answer at the end. I want to pay attention to my units. If I have centimeter cubed divided by centimeter, what I know is that I'm going to get centimeters squared here. And if I take the square root of centimeters squared, I'm going to end up with centimeters. So if you pay attention to your units, a lot of time your units do the work for you, and you end up having to do less work at the end. Now, units can be raised to a power as well. If I want to build a conversion factor for units raised to a power, I want to make sure I raise both the number and the unit to that power. So if I want to go from inches squared to centimeters squared, we have, this is the regular equivalency, the linear dimension. I have 2.54 centimeters equal to 1 inch. So let's square both sides, and I put those in parentheses. Well, what that means is I have this squared and this squared. So I get 2.54 squared times centimeters squared, 1 squared times inches squared. I can do this math and then get this conversion factor. And then what I get is this is equal to 1 inch squared. And this is going to be my conversion factor for the problem. So you want to make sure when I raise the units to a power that I raise the number and the units to the power. That's a critical feature for success. So let's look at these two examples. How many cubic centimeters, so that's cubic centimeters, are there in 2.11 cubic yards? So I want to go from 2.11 yard cubed, and I want to go to centimeters cubed. So what I have to do is look at some relationships. If I look at my centimeters, there is a relationship where I have 1 foot is equal to 30.48 centimeters. I also know that 1 yard is equal to 3 feet, right? This goes from English to metric. So this is measured. This one would have 4 sig figs. This goes from English to English. So this is exact, and it has unlimited sig figs. But those are the two things that I have to use. So I start with my given, 2.11 yard cubed. Now the first thing I want to do is go from yard to feet. So I have 3 feet times 1 yard, but this whole thing has to be cubed. And then I'm going to go from feet to centimeters. This whole thing has to be cubed. So what I have is 2.11 yard cubed times 3 cubed foot cubed, 1 cubed yard cubed times 30.48 cubed centimeter cubed over 1 cubed feet cubed. So my yard cube cancels, my foot cube cancels. I'm left with centimeter cubed. What I have to make sure is I raise those numbers to the power that they're supposed to be, right? So I have 2.11 times 3 cubed, which is 9. No, actually 3 times 3 is 9, times 3 is 27. So this is going to be 27 feet cubed over 1 yard cubed. So I have 2.11 times 27 and then times 30.48, also raised to the 3rd power. And this is going to give me 1613210.75 centimeters cubed. I have 3 sig figs. This is exact. I have 4 sig figs, so I'm going to go to 3. So I can do 160.0000, or I can do 1.6 times 10 to the 1, 2, 3, 4, 5, 6 centimeters cubed. And this is how I'm going to designate the fact that I have 3 significant figures. Actually, this is going to be a 1. So my answer is going to be 1.61 times 10 to the 6 centimeters cubed to 3 sig figs. Does that make sense? So let's look at this problem. This is a lot harder. A vineyard has 140 acres of Chardonnay grapes. A particular soil supplement requires 5.50 grams for every square meter of vineyard. This is a conversion factor that's buried in the problem. So I'm given 145 acres. I know I need 5.50 grams of the compound for every 1 meter squared of the vineyard. I know that 1 kilometer squared is equal to 247 acres. That's another conversion factor. And I want my final answer in kilograms. And I know I have grams in that conversion factor. So I have to think about how I'm going to set up all of these conversions. But this right here is where I start. So let's look at this. I have 145 acres. And then I know that I have 247 acres for every 1 kilometer squared. I also know that for every 1 kilometer, I have 1,000 meters, but I need to square that. I also know that for every 1 meter squared of the vineyard, I have 5.50 grams of my supplement, but I don't want to know how many grams I get. I want to know how many kilograms. So I also know for every 1 kilogram, I have 1,000 grams. Now this doesn't have to be squared or anything because I want to go directly from grams to kilogram. This has to be squared because I want to go from kilometers squared to meter squared, which is also here. So when I do this math, I'm going to have 145 acres times 1 kilometer squared over 247 acres. That cancels out. I'm going to have 1,000 squared, metered squared, over 1 squared kilometer squared. That cancels out. Times 5.50 grams of my supplement over 1 meter squared. So that cancels out. And then I need kilogram. So I'm going to use the conversion factor. For every 1 kilogram, I have 1,000 grams. So now I just do the math. And what I end up with is 3228.7 kilograms. 3 sig figs, 3 sig figs. This is unlimited because it's a definition. 3 sig figs, unlimited because it's a definition. I need 3 sig figs, so I want to go here. I can either say 3230 kilograms. Don't forget, I have the basically 3,200, so I can't just say 323. I have to make sure I have 3,230, or the easiest way to do this is also to do 3.23 times 10 to the 3rd kilogram, because then I don't have to worry about that 0 in terms of my sig figs. So this is how we're going to solve chemistry problems in a nutshell. And hopefully this made sense. If you still have any questions, don't hesitate to reach out to me and ask me questions, either by email or text. So I will see you soon with Module 2. This concludes the lecture for Module 1. I'll see you soon.